let's get started. So this one was interesting. What is your approach for any debugging any issue basically? So this one is again, like I said, it's very generic. It depends upon the system. It depends upon the application. How to because debugging an issue can the issue can happen anywhere. So usually the way I approach it is that the first thing that I do is like understand the system. Let me use the pen. Okay. Yeah. The first thing I do is like understand the system, because until and unless you don't understand the system, like very basic understanding of the system, what is like the input, what is the output, what is the expected behavior, what it should be doing, um, what are the different states of that at a very high level. Because if you don't have that idea, and if you just try to, if it's because especially sometimes happens that some like there's a tri-age engineer or a customer reports an issue, and then a tri engineer kind of says like, oh, I have narrowed down to this, and then you kind of dive into it. I have been in situations where the tri engineer was totally off, and what they told us, like, so you spend a few days trying to look at it, trying to see why is that system not behaving or that module not behaving as expected. It and you end up wasting a lot of time, and then you realize, oh, it's something else, and that was just a symptom. So first of all, understand the system, and the second thing after that is to reproduce the issue. Hopefully, it is a issue which can be easily reproduced. If you can do these two steps, then finding the issue or debugging it becomes much easier. So these are the first two steps. Once you have gone through these two steps, then you would be in a much better position. You would say like, I understand the system, I can reproduce the issue. um, Once you are able to reproduce the issue, normally the next thing that we do is that we try to see if it's an easy to reproduce issue or if it's an hard to reproduce issue. If it's an easy to reproduce issue, then you don't worry too much about what are the certain scenarios during which you can reproduce. If it's hard to reproduce issue, then sometimes just by seeing that when does it reproduce, it usually gives you a clue. But 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 in either case, is usually really helpful is that you add what we call like logging, or add like debug information, or add instrumentation, depending on your system, depending on your application, depending on what kind of system are you working on. So let's call this third step as add instrumentation. Add instrumentation / logging, because once you have that, you can it becomes much more easier to track through like what happens, what are the step of the sequences until the issue is reproduced. And it could be different, like I said, it could be different for different systems. One could be like, depending on if it's like a power electronic system, like you are basically trying to charge a battery, or you're trying to control a motor or something like that. One thing could be to actually add oscilloscope to the signals to see at like what is the signal looks like, and at what point maybe your PID controller fails, or at what point um, uh, your input changes, which causes an issue with the output. So um, just an example, one of them could be probing the signals. It could mean anything, right? It could mean adding a digital multimeter. It could mean adding a scope on it. It could also mean adding a protocol analyzer. Because once you know that you can reproduce issue, now you want to kind of dive into it, like at what step it's failing. So having that information, that helps a lot. And in some system, it's possible that you don't even have access to the signals. So in that scenario, what usually helpful is like having the logs. That's another thing that's usually very helpful. The third thing is usually if you're running a RTOS or something like that, again, it kind of falls under the logs, but like if you like enabling the crash logs, that helps a lot. If you know that the system is crashing, or in that scenario, what was the state of the tasks? So basically just enabling a debug build, usually that also helps. So these are all kind of fall under like instrumentation or logging, which are usually disabled in the customer application. Ashok. So once you kind of have some idea that once you kind of can see like at what point in the system your you can see an issue, because your system could be like, let's say it's like a pipeline. You take an input, like it's an audio input, you take it, it's analog signal, you convert it to digital, then you process it, and based on the process you make a decision, and based on your decision you update another module. So within that system, if you at one point, if you identify that over here a bug or unexpected situation or unexpected output is received, that doesn't mean that the system behind it is the cause of issue. It just means that any system behind it could be the issue. So normally what we do after that, after we have been able to um, find where the issue is happening, we then basically try to isolate the issue, or uh, isolate where the issue or where the bug is getting introduced. And the way you usually do is isolate the bug. One of the most common, or one of the most well known, is like divide and conquer, or I simply call it binary search. It applies to most of the conditions. Like over here, I explained, like if you can figure out that it's happening over here, then you look at how many modules or how many systems are behind it. Then you basically jump to the middle and see if you can see the issue over here. And based on that, you kind of do the binary search. Eventually, you get pretty close to the pretty close, or right, you target the exact issue point where the bug is getting introduced. Um, that's one thing. The other place where binary search is very helpful usually is that if you know that that the last build, like let's say there are nightly builds, or they're like weekly tests or weekly tests happening by QA, and you're saying like, oh, 2 weeks ago it was working fine, but now suddenly it's not working. Then you basically go 2 weeks back and make sure that it was working as expected. And then then you jump into the middle, like 1 week. If it was 2 week, 1 week back, you see if you can reproduce the issue. You do the binary search, and then if you can reproduce the issue, then it means that it happened between first week, or like 1 week ago or 2 week ago, between those commits. Then you jump to that commit between these 2 points, and then kind of over here. Eventually, you will be able to hit what is the code, or where the issue was introduced. So usually these steps are applied, and once you are able to isolate the bug, normally then after that you come up with an hypothesis, like it's an hypothesis that this is the bug, this line of code or this small module or this part of the system is introducing the bug, and then you have hypothesis that under certain scenario it reproduces this issue, or all the time it reproduces depending on this state of this other module. Usually the thing that I do is like I come up with a quick fix which shows that how which kind of counters that situation, counters that bug. It doesn't need to be like a bug which can be applicable to the all the states, but the idea is that, am I correct with my bug? Like what I have isolated, is that truly the bug, or is it like a sequence of bugs, or is it a few things which have to work together, or if that's just one instance where like, or is this bug is half the story? Like to make sure that your hypothesis is correct, you apply a quick fix or actual fix. If it's a simple fix, then you just apply the fix and you run it on the latest commit or latest system where it was getting produced, and you see if you can reproduce the issue or not. If you cannot reproduce the issue, then it means that that's your that you're right, that part or that code or that lines of code are the basically the smoking gun. Apply a quick fix to ensure the isolated isolated is correctly ID'd basically. So it's so that the isolated bug is correctly identified. That's the last step. Any questions with this approach, or anything which doesn't make sense, or any comments? Again, this is like a generic, somewhat generic. I've tried to give you some examples, but again, it differs from system to system. In some systems, some of these steps may not be possible. So this is like generic, but of course, depending on the application or even depending on what kind of job are you interviewing for, it should differ. Like for some instances, it's possible that the application they are talking about is a variable and it doesn't have logging. Then it would become, or it doesn't even have enough space to like add like logging. Then based on that, you will probably be expected to use something like GPIOs to show what is the state, and then you can kind of like say like, oh, assign these 4 GPIOs to encode the states of the state machine. So again, it depends totally on what kind of system you are on, and what kind of debugging tools does it have. Another big one that I haven't mentioned over here is basically the uh, like tracing, or basically stepping through the code. Stepping through the code helps once you have kind of narrowed down which function, routine, or which part of the system is causing issue. Or basically, you can reproduce the issue over and over again. Even then, it's also helpful. But again, it kind of falls under the instrumentation or logging. Once you can reproduce the issue, you basically add instrumentation, logging, or tracing to it, and you try to see if you can isolate the bug that way. Okay. Um, moving on. Yep. Go ahead. Heard
Hi, this.
someone.
Can
Yep.
you hear me?
Yes, I can hear you.
Yeah. Hi, my name is Vash. I mean, this is pretty good. Uh, I mean, this if you look at step one and step two, that kind of applies to pretty much apply to all the problems, and then even step three and four or are kind of, I mean, would apply to all the problems, but then the specific mechanisms might differ. Like, right, as you said, it depends on the context. For
Yep.
step two, like because you mentioned in that you work for Tesla. If we think of a scenario where, let's say, there's some issue which is happening on the field, how would you
Yep.
reproduce that? How would you reproduce on? I mean, reproducing on a on the field might be costly, dangerous, right? So what are some of the techniques that you might use? Simulation might be one, but
Yeah.
anything.
Simulation. Yeah. So I mean, if something is happening in the field, um, the first thing we basically ask the system integration, the QA team, is like if they can reproduce it, or if they know the steps which cause the issue, or even what kind of issue it is. Because just knowing what kind of issue it is, sometimes that's helpful, at least in narrowing down to like where the issue is happening. Then it kind of helps narrow it down a little bit, because the whole idea is like we want to narrow it down, right? like where it's happening, because it could be a big system. Like let's say a supercharger, right? A supercharger in the middle of a desert. It once in a while you see issue happening only on that one. You cannot like add instrumentation to that. So what usually, I mean, in this instance, we kind of already have added instrumentation or logging because it's a big system and it's like powered via the grid. Like we actually have the grid connected to this. So in that instance, we don't worry about power drain or something, some other things like that. So we can add like actually memory and a lot of memory and flash memory and stuff like that, which is very helpful. But to answer your question, if it's happening at customer location and it's not happening, it's like you don't know how to reproduce it locally, then that's one of those scenarios where sometimes I don't really suggest that, because it ends up it ends up becoming like an effort where a lot of cycles are wasted. But code path analysis we have done, where we looked at the code and tried to see if there's even a path where the user can get stuck in a certain scenario. um Again, it depends on the application and depends on the issue that they're saying, like, but we try to see if there's any scenario where they would get stuck in that state. And then kind of try to see if we can somehow reproduce that locally, or what are the edge cases using which we can reproduce it locally. That's another one. That's one way to do that. Other than that, it's again, like I said, it's very specific to the application. Does that answer your question?
Yeah, yeah, that makes sense. I mean, there are two objectives to reproduce the issue. One is to debug the issue and find where the issue is, and then fix it.
Yeah,
But the second, even more, I mean, second other important aspect of it is, if you can reproduce the issue, then once you put a fix, you can test it out, right? But
yeah,
if it's in the field, we could get the logs. We might, from the logs itself, we could figure out, okay, this is the issue. Might fix the software, but then how do you test it? You might have to deploy it, uh, even without actually make. You might have your intuition and things like that, and you fix it, but you haven't tested until you reproduce it, right? So
yeah, yeah. And this one is one of those that depends, like depending on how many customers you have. Like if the only customer you have is like 1,000, like superchargers, like it's kind of like internal product, right? If the customers are basically yourself, or like you own the product and it's just that other people are using it, then you may be able to get like correct data. But if it's like a customer owned unit, or like out of millions only 1,000 or 10,000 see that issue, it's like, again, it depends on the application, then it becomes much more trickier. Then it kind of is also like your best effort, like you try make your best guess and then you apply the best effort, and that hopefully would solve the problem. If it still doesn't solve the problem, then another way is to basically reach out to the customer, see how can they reduce the issue, or ask them for the faulty units. And in the past, especially in consumer electronics, there have been instances where you end up finding that it's a hardware issue. There's nothing the firmware or software could have done to resolve that. Um, yeah. So there are instances where you you probably won't even be able to figure it out just by applying these debugging techniques. It's That's why engineering is hard.
okay, makes sense. And I think you also touched on the other point, where how much instrumentation or logging that we would probably like to add by default in the system, right? It all depends on the context. Like
Yeah.
in supercharger case, you said you could put up not a lot, but there is lot of flexibility to put lot of logging and instrumentation. But in a system like, I would guess, like an airport, where you might be constrained by the memory and the battery and things like that, so you might want to just have a selective one. But then when you hit the issue, your debugging process might be little more painful in that case, right? So
Yeah. So usually you kind of there's no like rule of thumb kind of thing, but one thing that's really helpful is like if you get crash logs, because crashes shouldn't be happening too often. If they happen once in a while, crash logs are really useful. The other thing you can do is like get high levels state machine states. Because if they are high level enough, they shouldn't be changing that often. That helps, because, and then depending on how much space is left, then you can also kind of um, start logging things which are most user facing. In case of AirPods, you can think of something like, oh, when was a device connected via Bluetooth? When was a device connection was lost? When was a user pressed a button? When did a user started playing, or when was the Bluetooth audio started receiving? Because just using these limited number of events, user events, then you can kind of, if you see that, oh, the bug happens after the user press the button, then that helps you a lot, because then you can kind of say, okay, it happens after that event, so maybe we can, it helps you in reproducing the issue, you try to do the same thing. Or if you see a crash log happen after a certain event, so depending on, again, it depends like how much space, or like RAM space or non-volatile memory do you have where you can store all these events. It also depends like what kind of infrastructure do you have in place to actually log these events. Um, yeah, so it's totally dependent on the application, but it helps a lot if you have that logging or crash logs enabled.
makes sense. Just one last question, like how would the in an airport scenario, how would the crash log be captured? So it's like when the crash happened on the next reboot, you would capture the crash log and save it in the flash, and then once you go to the application, it will transport over the PLE or the
So I won't be able to talk specifically about airports, but I can talk in general. So
okay.
in general, we have RTOS, right? And RTOS, a lot of RTOS give you this flexibility where if it crashes, it goes into the memory fault handler or hard fault handler, or like whichever fault handler it goes into, or like assert happens, right? So assertion handler over there, usually they give you this, that you can store it in certain location on the flash, or on the non-volatile RAM. Usually there's some space associated just with that, and then you reset. And when you reset, you boot up, you basically read it from the RAM, or if you already stored it in the flash, that's good. If you didn't store it in the flash because you wanted to reset instantly, you read that information from the RAM, and you basically write it to a non-volatile memory, or, and when you get the chance, you transfer it over any serial communication or any wireless communication, or you write it to like a memory card, whatever is the interface, and then eventually, hopefully, the app or the whatever your device connects to it can transfer that information over, if it's an IoT device, over the internet to the company. And then the other question is, what do you want to store when a crash happens, right? Before you lose all of that information. Usually it's the stack information. What does the stack look like? It also stores information like what is your function name. Like asserts are really good. They actually store what caused the assert, what is the line number, and what is the file name. That has helped me a lot in the past. Um, but all of this does is not free. Usually, all of this comes has some cost. Like in case of asserts, usually there is a string, like a print, because it's like a print f associated with that file number and that line number that gets stored in the code space. So usually each assert you use, it basically whatever is that number of characters, like could be 4 to like 32 bytes of string associated with that. So if you were to ever answer like this in interview, they might ask you what is what are the pros and cons of using this kind of crash logging, that there is a hit on the memory. And if you're using like a very small wearable device like AirPods, which has very, because of the space constraints and battery constraints, like very little memory on board, then these are some of the things. With asserts, there is one way where you can store information without having to store a lot of strings, which is program counter. So if you store the program counter, usually program counter is dynamic, then you can later on map the program. So you store two things, program counter and the git commit hash. It could, so that whatever is that, like 8 bytes of git commit hash, or and the program counter value, usually using that, then you can find the map file for that firmware image, and then you can see like which function was the function, was it at that time when it asserted or when it crashed. So these are some of the ways you can add crash logging or assertions and then use them.